Hi, I'm Dr. Neenu Garg. In this session, I will discuss shortest job first scheduling algorithm. Let's start. Shortest job first, or short form is SJF. This algorithm associates with each process its next CPU burst. Next CPU burst. And when CPU is available, it is assigned to a process which has least next CPU burst. The process which has least next CPU burst. If two processes have same next CPU burst, then tie is broken using FCFS. Okay. Another important point about SJF is it is a non-preemptive scheduling algorithm. It means if CPU is allocated to a process P1, because P1 has the least next CPU burst, then P1 will hold the CPU until it leaves the CPU after termination, or it voluntarily leaves the CPU for some input output. It will not be preempted from CPU. If some other process with least CPU burst come in the system, even then P1 will continue its execution if it is already allocated to CPU. It will not be preempted for process P2 by the scheduler. It is a priority based scheduling algorithm. The priority in this case is least next CPU burst. So CPU will be allocated to a process which has least next CPU burst. So least next CPU burst is the priority. Okay. SJF gives a minimum waiting time for a set of processes. How? We have already discussed this factor in when we discussed first come first serve. But let me just revise you this concept. If you just move short processes, first to CPU, then the waiting time of short processes decreases. So in this case, the average minimum time will decrease. Let's understand SJF with the help of an example. We have to complete this table using SJF scheduling algorithm. And what we have to find? Average turnaround time, average waiting time, schedule length, and throughput. I will discuss about schedule length and throughput. So let's just start first. So we always plot first, yes, Gantt chart. Okay. So in this case, let's just plot a timeline. We'll start the timeline or Gantt chart from 0. From 0 to 1, there is no process. From 0 to 2, there is no process. So CPU is idle. See, we are just assuming this thing that from 0 to 2, CPU is idle. There was no process in ready state. At time 2, process P1 come in system. So at time 2, there is just one process in system. So there is no choice for SJF scheduler. Okay. So P1 will start executing. And once P1 will start executing, if at time unit 3, some other process comes whose length of next CPU burst is shorter than P1, but still it is a non-preemptive scheduling algorithm. So P1 will continue to execute. It will execute for, yes, it will execute till 5. Why? Because its burst time is 3. From 2 to 5, it will execute. Okay. Now at 5, till 5, yes, we can see process P2 came in system, process P3 came in system. But the burst time of P2 is 2 and P3 is 3. So the process with short burst time will be allocated. So out of P2 and P3, scheduler will select P2 to execute because it has least burst time among all the available. Okay, so it will execute till 7 because its burst time is 2. Till time 7, P4 is also in the system. Okay, we are done with P1 and P2. So now the choice is for P3 or P4. Scheduler will check for their burst times. Burst time of P3 is 3 and burst time of P4 is 1. Which has shortest burst time? Obviously P4. So P4 will be given to CPU. It will execute for 1 time unit. At time 8, P5 also come in the system. Now we are left with two processes, P3 and P5. So scheduler has to select between P3 and P5. Burst time of P3 is 3 and burst time of P5 is 2. So which process will be scheduled on CPU? Very good. P5. It will execute till 10 time unit. Okay. So yes, there is no more process. So P3 will execute. So this is a Gantt chart that you can see for SJF for this particular example. Now we will find all these values. CT is completion time. Yes, what is the completion time of P1? Completion time of P1 is 5. Okay. Completion time of P2 is 7. P3 completes at 13. P4 completes at 8. P5 completes at 10. Very good. Now let's come to turnaround time. We all know that turnaround time is completion time minus arrival time. For P1, completion time is 5 and arrival time is 2. So it comes out to be 3. Turnaround time for P1 is 3. Similarly, for P2, completion time is 7, arrival time is 3. Turnaround time comes out to be 4. For P3, completion time is 13 minus arrival time 4. That gives me 9. Turnaround time of P3 is 9. For P4, completion time is 8 minus arrival time 6. That gives me turnaround time 2. For P5, completion time is 10. Arrival time is 8. That gives me turnaround time 2. Now, average turnaround time is 3 plus 4 plus 9 plus 2 plus 2. That is adding all the turnaround times with number of processes. So that gives you 20 by 5, which comes out to be 4 milliseconds. So average turnaround time is 4 milliseconds. Similarly, we can find out waiting times. Waiting time is turnaround time minus burst time. For P1, turnaround time is 3, burst time is 3. So waiting time comes out to be 0. You can also verify it from Gantt chart. P1 arrives at 2 and it was also allocated CPU at the same time. So it does not have to wait. P2, turnaround time is 4, burst time is 2, waiting time is 2. P3, turnaround time 9, burst time 3, so waiting time is 6. P4, turnaround time is 2 and burst time is 1, so waiting time is 1. P5, turnaround time is 2, burst time is 2, so waiting time is 0. You can also verify this time from here. See, P5 comes at time 8 and as soon as it arrives, it was allocated CPU because its burst time was less than that of P3. So it does not have to wait and we can also verify it. It is also 0. So let's find out quickly average waiting time. It is 0 plus 2 plus 6 plus 1 plus 0 divided by 5, which is equal to 9 by 5 milliseconds. Okay. Now next is schedule length. What is schedule length? Schedule length is the time from where the scheduler starts scheduling to the time when the scheduler ends scheduling. In terms of formula, we can write it as it is the completion time of, basically in terms of formula, it is completion time of last process minus arrival time of first process. Scheduling, when scheduling started? When first process arrives. First process arrives at 2. And when scheduling ends, scheduling stops at when last process in the system complete. The last process in this case that complete was P3, and P3 completed at 13. So we will subtract the completion time of last process and the arrival time of the first process. 13 minus 2, that gave me 11. So the schedule length is 11 milliseconds. Next is throughput. We all know that throughput is the number of processes completed per unit of time. Okay, we have to find the number of processes completed in per unit of time. In 11 millisecond, how many processes complete? 5 processes. I'm talking about this example. In 1 millisecond per unit of time, 1 millisecond is per unit of time. In 1 millisecond, how many processes completed? 5 by 11 processes. So the throughput is 5 by 11 processes per unit of time, per millisecond. This is the throughput. So we can also write throughput in terms of formula. You can write it as number of processes. You can note it down, divided by schedule length. So this was all about this numerical. I forgot to write 0 here. Okay. I hope you understand SJF. Thank you.